actually walk the talk and write the talk. So I've been in application security for a very long time, doing this for telco, banks, and so on. I'm going to talk about this later. Who knows what reachability analysis is? Hands up. Reachability analysis.
I think this is a new topic for a lot of people.
Really?
Yeah. So many people hit me up. What is it? I'm like, come listen.
Yeah, that's the right space to be. So reachability analysis, as guys say, is a new topic. It's a new thing to actually squash in vulnerabilities on your container, on your software. But it's actually relate a lot to SBOM, how we do fundamentally libraries, how we link libraries inside container, how we build software. So it's not a new term, it's just a new way to actually use this methodology, if you want. But I've been around a lot. I've seen really bad thing happening, and reachability analysis is probably the only good thing that has happened in application security in a long while after SBOM. Who knows about SBOM here? Good. Who hates SBOM here? Yes, no? Love it, hate it?
Debatable.
It's all about asset, but that's my opinion. But I've seen organization fixing problems with really stupid methods. Nicole, you have seen your fair share of drama and stupid stuff.
I have a question.
Yes.
So we've been doing this for a little while. You've been doing it for a little while. Nicole, how come we didn't hear about SBOM like 9 or 10 years ago? It's just ridiculous because it's really something we really should have had like 20 years ago.
Well, there wasn't regulation about it, so it wasn't cool to talk about libraries, SBOM. So now there is regulation about it. SolarWind happened, Log4j happened. There's been a series of events happening, so we care about open source lineage of software posture, and we start using container much more, we start using the cloud much more, libraries are everywhere.
There you go. It's I forgot. It's common sense. It's more or less when it came to cloud came.
Yeah,
That really makes sense. I have Angie coming.
It's just complicated. So I hope you like memes, I hope you like jokes, because I love it, and security is depressing enough if you've been in this industry, in this field for quite a while. So if we do it with a smile, if we laugh about it ourselves, the industry a little bit, we'll probably survive a little bit more. So as I said, a little bit about me. I've been in this industry for quite a long time. I've been in banking for quite a long time, helping them, doing the first baby step into the cloud, modernizing mainframe and very old stuff into modern stuff. So I've seen my fair share of drama. Guy probably have seen the other fair share of drama. And I've been in telco as well. So one of my favorite sentences is, you can argue with people, but you can't argue with data. So a lot about this presentation and what I talk about is a data-driven approach on application security, is a no BS approach on application security, because it helps you winning the argument. So we're gonna go a little bit on a journey on why, as Guy said, we have this drama about SBOM, application security, why the industry has become so complicated. And we're gonna go on a history from 2015 to today, fast track, I promise you. And then we're gonna see what are the challenges basically on prioritization in the modern world, not in the old world, how to do it right with reachability analysis, and then wrapping it up all together with risk. So I'm not that old, but I've been in this industry for quite a little bit of time. Who has been doing application security or any sort of security in 2015? Raise hand. 2015. Okay. Guy, how did we used to build application in 2015?
Spaghetti code?
Yeah. Container? None?
No.
Cloud, none.
People just clicking away.
Exactly.
No collaboration of sort. Everyone was in their like own little world, and then either really good teams would get together every night, but mostly it was like every week or every 2 weeks.
Yeah, but we used to have monolithic application. We didn't have a lot of API. We had a bunch of web servers. So the landscape wasn't so dramatically complex, and we didn't have a lot of declared vulnerability or accessible vulnerability. So people weren't just going around downloading scripts and launching scripts against API. You actually had to write your own malware. It was a bit more complicated. In fact, we had 15,000 vulnerability versus the 220,000 plus vulnerability of today. I think this year we hit the record of 40,000 vulnerability declared. On one end, there is more regulation, there is more maintenance around vulnerability, so there are more companies that declare them as soon as possible. On the other side, it's easier to download exploit and to launch exploit, and it's much more complicated to live in a world where we build software, we ship software, we build software inside container, we ship container anywhere on the host. It's all transient, so protecting your environment, segmenting your environment is much more complicated. Understanding where to fix or where the heck is my posture, what's my application, is becoming very fluid and much more complicated. We build software, we ship it inside container, and the container migrate around a number of hosts. And if we try to patch stuff or to fix stuff in the method that we used to live and use back in the days, we're probably very lost. And I've been here, so I feel your pain if you are in this journey. I maintain team that were completely lost and were trying to apply very old method to this new world, trying to patch container, trying to upgrade a container, trying to even figure out where a container is nowadays is fairly impossible. Understanding which application is built where, which library is actually spun up where, which library is actually active and reachable, and that's hence the term of reachability analysis. It's very complicated if you don't have a good asset inventory, software inventory, but even building one nowadays is complicated, and hence the term SPOR. But vulnerability are increasing, but attacker are increasing. The budget for defender is not increasing. I think we have only 6% increase in terms of spending, and probably this year we've seen a decrease in terms of security spending. We have more regulation, more vulnerabilities, and that's what I call the attacker gap. So that's where people tend to develop things. And if we're lucky enough, we're probably gonna hit by 2031 a million worth of declared vulnerability. So we're not slowing down. We're accelerating in terms of vulnerability being declared and being announced. And one of the elements of acceleration is that we write more code with AI. We put AI in the hand of people that have no clue about security. I'm not demonizing, I love AI, I love LLM, but you need to use a tool as a tool, otherwise you become the tool, and that's my standard favorite sentence. You can quote me, I love that sentence, but it's actually true. You can fire up your favorite LLM, Chinese or non-Chinese, ask him to write a piece of code, it will probably write crappy code. But if you ask in a specific term, can you write these things, applying OWASP top 10 principle, applying good security principle, it will write a very different level of code. The problem is, who knows it? No one. So we're gonna inherit a bunch of crappy code, and not only that, there is also GPTs of various sense that produce malware. So creating malware, we don't even need to go and try to download it. We can have automatic declared malware. Now the opposite of that and the consequence of that is that there is also malware trying to scrape open source code. CURL is probably a good example of that, with probably a vulnerability declared every week as a bug bounty, trying to fundamentally claim those bug bounty prices with LLM. And the funny part is that I read some of those declarations, and they actually made sense. So the LLM spit out very good vulnerability report, even though they make absolutely no sense if you go deep into it. Nonetheless, we have a whole industry that is pushing to actually develop exploit very quickly, and that's why the exploitation time has gone from 15 minutes roughly to 3 minutes. So to identify a problem and to exploit it.
Are you saying 3 minutes? Because, you know, work with AWS and they say it's lower than that.
Potentially, yes. This is one of that. This is from when it got declared to the first evidence of exploitation in Cloudflare. JetBrains, very popular, TeamCity, very popular IDE tool, so it's easy to get into developer consoles, exploit code, inject other code in other pieces. So we don't have a lot of time. So either we automate asset inventory management, knowing who does what where, or we lost the battle. And again, I'm not doom and gloom. I'm going to give you some solution, some way to go about this. So I don't want to be
That's
just.
why Phoenix is here.
That's why
Come
Phoenix
on.
is here.
Educate us to beat them up instead of them beating us up.
Well, the first things that we did with Phoenix and in general with as an industry is we try to understand where was the problem. The problem is we talk about application security, but we don't talk about operational security. We don't talk about cloud in the context of application security and the other way around. We have two folks that talks in two different ways, but it's the same stuff. We build software, we put software inside machines, those machines runs in the cloud. We can't approach the problem with two ways. But if you talk to operational people, they talk about threat actors, patching, and so on. If you talk about software people, they talk about security champion initiative, maybe SLA if you're lucky. We talk different language, but the problem is the same. Who has tried to talk to AppSec people or to developer and to operational people? You gonna talk the same language? Have you tried it? No?
You fixed it all with DevOps, right? I thought
Well,
DevOps solved everything.
DevOps was supposed to be
Or DevSecOps.
blurring this line and building and owning your own code, but it didn't end up being that. Like, I think DevOps failed in a way. It created a new wave, but it kind of failed because Dev and Ops are still separated. We don't throw code around the fence, but we still haven't fixed, or we still haven't blurred this line. I think we are going to, because now runtime and software, or environmental security, call it whatever you want, I call it runtime or environmental security, and software security are becoming blurred. But the problem is right now, how we address or how we solve vulnerability. Well, we launch a bunch of scanner if we're lucky to have a bunch of scanner. OWASP has a bunch of them. We just throw the result to the developers and we just say security said so. So just go and fix all of the critical that are spit out there. And we call that a zero risk approach on vulnerabilities. But it's actually a very stupid way to address vulnerability because you end up fatiguing everybody. Who has launched an SCA scanner or an open source library scanner for the first time in a very mature environment, or a vulnerability scanner of the sort?
May I run it for SBOM?
Sorry?
I ran it for SBOM.
How many vulnerabilities spit out?
I don't want to talk. It was all red.
How many?
So for 1 minute, it was around 500. But we cut it out. Control C before it.
You hit the upper limit.
We see client with 30 to 60 million vulnerability and probably 1 or 2 million critical or supposed to be critical. So trying to fix them all is impossible. It's not even reasonable. And that's kind of the life cycle of the vulnerability management process, where we just throw stuff at devs and then we complain that those complain back, saying we have too many things, it's not our job to do security all day long, and they're right. We just need to find a balance. And the problem is, we try to make it important for them. But for their boss and the boss of their boss, it's not important. So unless it's important for your boss, it's never going to be important for you. If security is not pushed top down, it's never going to be important. But this method actually ends up just flooding backlog of engineers with tons of vulnerabilities without highlighting the one that's going to get a breach. Because as defender, we need to fundamentally try to eradicate as many as the more likely to be exploited vulnerability. As attacker, we need to find 1, 2, or 3 ones that are going to get attacked. And then as a bonus, you have shock exec when, hey, we pushed SLA down. Why SLA were never fixed, or why the important vulnerability were never fixed? Or my favorite one, we bought a scanner. Why haven't we fixed vulnerabilities?
Or we bought a scanner, but we haven't deployed it yet.
That's even more one. We bought a scanner, where is it, and why is it not reporting vulnerabilities? Why isn't it fixing for us? But jokes aside, even with the scanner, the question is, why can't we be secure? And in the past 3 or 4 years, we actually had a flurry of superstar vulnerability. Like Log4j was a superstar vulnerability. We had Palo Alto 1, TeamCD, HTTP2, CURL, all of these in itself were critical vulnerability, super hot vulnerability, or superstar vulnerability. Each one of them could have taken the internet by the storm. Like Palo Alto, tons of machine exposed, remote code execution, as bad as it gets. TeamCD you can get in the ID. Now those are the superstar ones, those are the important ones that should be fixed first. But if those are buried down a sea of problems, a sea of vulnerabilities, it's unlikely that you're going to address them first. So we keep on asking the question, how many vulnerability or how many problems should we solve? And that's a wrong question to answer or to ask. We should ask the question, who does what where and how important it is? Who should fix what where and how important it is? That's the question we should answer. We should ask. Now, to ask and answer that question is challenging because it means that we need a concept of ownership, who does what where, which repository is maintained by which person, which group of people or developers actually are maintaining which container, where is it running, how exposed it is, and then how many vulnerabilities does it have, and how important is the system that runs in there, a set of questions. So we can get a little bit of a shortcut in that. Is the library really reachable? So I'm going to go quickly on a couple of slides just to show how stupid the approach has been so far. So far we've been fixing roughly, this is a Gartner report, so I don't love Gartner, but it speed up some decent reference data. Exploitability time is 3 days, actually it's 3 minutes nowadays, and we have average fix rate on critical 15 days. And then it goes higher and higher. And then the answer to do this is basically push SLA or service level agreement or objective to actually fix vulnerability to system or to teams. And Gartner has done a study. It's basically those objectives are completely delusional because we never hit them. Because we spread them across all of the vulnerability, and instead of just saying, hey, fix the one that are more important, we ask them to fix them all on a time frame. So it's the stupidest way to address it, and this is the evidence. Again, I love data because it tells a story, and you can tell anybody how stupid an approach is by showing this or other data point. And just to give you a perspective of how many things getting declared, the picture, the part on the right, but how much stuff is actually exploitable and implementable from an attacker? It's a fraction, it's a 1% probably. That's why I love the 1 or 5% of vulnerability that really matters. It actually has legs. So, did I paint enough doom and gloom? I've been in here. It's hard. Like, writing software is hard. Organizing software is even harder, especially when you start in an organization, when you start organizing stuff, where you're the first AppSec person in that line, to try to tell them you should do things right. It's hard because people want to go fast. Developers want to go fast, business want to go fast, especially nowadays. So it's a process of introducing specific things, but it's a process of also introducing automated things. So I'm going to start talking about some level of automation and how can we really prioritize what really matters and how. Now, I say I want to blur the line between application security and operational security or runtime security, and here I give you two different methods of approaching the problem. So yes, I want to blur that line, but also we need to recognize that operational security, cloud, container work in a different way than software does. They have different methods to prioritize. We have different methods and different data points to prioritize software with the reachability analysis that I'm going to cover in a second. And operational environment, we patch those systems where those vulnerabilities are. So container OS, things that runs in the cloud like an AMI, some other things like misconfiguration, we can leave them a second. But those two things are correlated because software runs on these things. But the methods on how we fix a problem in here and we prioritize the software in here, a piece of things installed in here and a piece of software written in a repo is very different. So some method that we can use to actually burn down the 200 plus vulnerability is just taking the first approach on like, look at everything that is being declared in a bug bounty program across 17,000 vulnerabilities, and you already go from total number of vulnerability to a 4%. What's exploitable right now, what's kicking around in terms of exploits, 9,000. What CISA have hopefully will survive, or what CISA and other have system or non-exploitable vulnerability are around is 1,000 to 2,000 vulnerability. So we're gonna even below the 1% of vulnerability that matters.
That's what you know of.
That's what you know, but
right.
Those are the things that are low-hanging fruit. So if we need to choose something, choose these.
Well, there's a lot of O days out there that.
Who would choose an all day to attack a company? It depends who you are.
I'm going to tell you there are.
There are 0 days. There are 0 days, absolutely. I'm going to touch this in a second. Those are one of the factors to consider. If it was a 0 day, it's more likely to be exploited later on. Somebody's using a 0 day, but the likelihood that somebody you're going to use something that they can download it and launch it automatically, or methodology of attacks that actually are in 0 days, we can see them later on, are more likely to hurt you statistically than a 0 day. A 0 day needs to be developed. It's very precious, it's very expensive to use. It's sold to a very high price because nobody has developed a patch for it. So it's very popular for certain governments to attack certain systems, but it doesn't happen every day. These happen very frequently on a daily basis. Now, on top of all that, we can possibly scrap all of that for libraries. Like libraries, open source systems are a very different beast. So exploiting a library is not the same as exploiting an installed software. So for installed software, these are really good way to prioritize things. For library, where they are deployed, are they reachable? Is the asset or the application where they're running critical? Those are good way to prioritize. But before we take a step back, Who knows the concept of exploitability? Who can define what exploitability means for a vulnerability? Wanna try? Guy?
I'm gonna let someone else answer.
Nicole? Come on.
There's a lot of words that can go behind that word.
Give me a couple.
I'll do that. Yeah. So that is a good question. Vulnerability versus exploit, right? Exploit is the warhead that sits on top of vulnerability. That's sort of the analogy.
But what define if something is more or less exploitable than something else?
It's more exploitable.
Yes.
It's the impacts and likelihood.
Yeah. That's good. It's a good way to put it.
He's my smart friend.
So popularity. How popular are specific exploits? How many times have been somebody created a POC or a proof of concept in GitHub? Nowadays, there is even malware delivered through the declaration of exploit. I've seen a couple of examples of people writing piece of code so that people download that piece of code thinking, hey, it's a 0 day, I can use it, I can sell it. They installed it, and there is malware in there.
They don't do that in beepers, do they?
Sorry?
They don't do that in beepers, do they?
But you have some data point as well, GitHub, bug bounty, to see how popular specific exploit or method of exploit are. As Guy said, was it a 0 day? There is Google that has a 0 day project. Was a popular one, been stopped for a while, now restarted to document, especially on Android, 0 days before they get patched. Trend Micro has a 0 day project as well. All of this stuff, by the way, is available on the website. We actually do a lot of data capture and data documentation to show you a lot of these data so that you can go around and feel smart showing data and shutting people up with data. All open source because we love open source. But one of my favorite one to classify how likely is something to get exploited is it automatable? And you can use vector analysis on CVSS, on CVSS score, or classify or CWE for identifying what's remote code execution or typology of things that can be launched remotely. Those are the more likely to be exploited because it's code that can run, you can launch that code from somewhere else and is remotably exploitable. So any of the popular web exploit are actually of that category. And by
Sorry,
the way, before you ask it, we have data about it.
Could you explain like automatable? So you're looking at like environmental scoring it and saying what's the reachability,
Correct.
right? So
Yes.
you're
So
automating that.
CVSS has particular part of the vector that says, can this thing be launched remotely?
Yeah.
Now, CVSS is done statically, so sometimes stupidly, sometimes badly. But if you don't have anything else, there is a piece of the vector that says, can this exploit be executed remotely? And that drives the score high or down. That's, in absence of anything, you can use the network vector that is the part of CVSS or common vulnerability score to identify something that can be used remotely. In absence of anything, that's a good way to prioritize data. CWE are becoming a bit more popular. We're fixing a lot of CWE or common weakness enumeration to actually prioritize things. Yes?
Quick question. You're talking about the places where we can find vulnerabilities, right?
I'm talking about the places where you can identify the likelihood of something to become vulnerable. You can find pieces of vulnerability in all of these places. You can find the same vulnerability in all of those places. Like something can start as a 0 day, it start having links on GitHub. Log4j has around 250 different GitHub repositories with exploit available on them. It started as 0 day, it's a remote code execution type of attacks. If you look at EPSS, for example, or exploitable score, that is a scoring system that we use and we created as well to measure how many times a particular vulnerability gets exploited in the world on the network, is another good reference data point to determine if a vulnerability is actively used in an automated way in the wild. Again, they're not the 0-day, but they're one launched at scale to actually target any system that is on the web. We capture that data together with other threat intelligence communities. We centralize it and we open source the scoring system for free. Now, caveat, because this system is used as network level, we can only detect things that traverse the network of a specific type, that is remote code execution type of attacks. So don't use that to prioritize vulnerability in your open source software, because it's the worst things that you can do. And 80% of the industry is doing that. So if you want to be smarter than 80% of the people, don't use that, use reachability analysis. Question on this?
Take the mics and put one on each table this
Yes.
way.
You guys can pass it around.
There's one more.
Don't talk both together.
I got a question.
Yeah, sure.
Which point does Phoenix concentrate most of its time?
We concentrate in this and everything else, but we found that using the likelihood of exploitation, so we use this information to actually understand how likely it is for a particular vulnerability to be exploited. So we use this as part of our risk scoring calculation to say, hey, this is more likely to be exploited than another one. But in this analysis over the years, we found this is great for installed product, your Windows issues, your Linux issues, but it was absolutely crap on libraries. So we used this and we found that it was pointing to the wrong direction. So we need to find a different way. Container vulnerability, again, is absolutely crap, because the majority of container vulnerabilities are actually the software that get built in there. So this wasn't a method that wasn't helping us, but this is a method that solves a specific problem for a typology of operational vulnerabilities.
Got it.
Yes, can you pass the microphone? Thank you. Sorry, your name?
Tim. Is this the whole realm of the CTI?
It is a part of the realm of the CTI. The CTI, or cyber threat intelligence, helps organizations identify evidence of certain element of this by looking at, hey, is anybody in certain forum talking about a specific vulnerability and driving, hey, this is the evidence of it. There is some CTI vendors, so CTI is very opaque, it's a very close community, so there is a lot of misconception about, hey, there is somebody that in a room, closed door, is talking about this, and you have absolutely zero data to prove that. So there is a lot of buffoons out there that talk about CTI, and buffoon is really the very gentle term, as you've seen. I had to think a little bit about it to talk about this stuff. There are others that actually are using CTI and are part of incident response. Mandian, part of Google, is one of them that is very reputable and has been out there and has evidence to prove that that data is actually, there is some veridicity around it. But sometimes they can be very expensive. We make CTI available for all the WASP community because it's not as good as Mandian is, the one that we give for free, but we make it available for everybody to actually use it. Yes.
What are the main infrastructures that y'all focus on when it comes to security?
Infrastructure, sorry?
Like the Azure, like AWS.
Everything. Everything.
Anything in the cloud, right?
Anything in the cloud, on-prem,
Okay.
software that you build, where you ship it. Like, we cover the whole SDLC. We try to focus on everything because you don't secure just one piece of software and then you ship it somewhere else that is vulnerable, because then that piece of software becomes vulnerable. If you're shipping a piece of software, you fix your OS open source library in there, and then you ship it on an operating system that has SSL port open or misconfiguration on that container, or a vulnerability in that container, it's pointless. So we need to focus on the whole life cycle of security to be able to identify and tell you the likelihood of this particular application in this particular environment deployed in here is this. We need to look, unfortunately, on the full stack. That's why it took us long to actually build a whole system, because it's a very complex thing to do. And there are very few of us that actually do that in a proper way. That's what we're backed by a lot of CISOs. And then the last part is actually cyber threat intelligence. Sorry, did that answer your question?
Yeah.
Great. The last part is actually paid or open source threat intelligence that tell you, hey, these particular vulnerabilities we see an evidence in the wild or in closed door, or even better, as part of an incident, because that's how you detect 0 days. Hey, somebody has used this particular exploit in here. That's when Mandiant is really good. But yeah, if you wanna create a pyramid of from more stupid to more intelligent way to prioritize things, you start from your soup of security name, SAS, SCA, DAS, pen test. So those are your scanner, and this is the raw data that the scanner gives you of, hey, you have a critical. It's non-contextualized, you don't have any logic around it. And I can't talk as fast as my slides, but yeah. The second level is how important is the application or the system where this particular problem manifests, how likely it is that this particular vulnerability appear. Do you have evidence of actual exploitation, the things that we just discussed? What is the likelihood of this particular problem to be exploited in this particular system, in this particular area? And the last part is the contextual area and the reachability analysis they're gonna talk in a second. But to answer your question before, this is the system, or this is a normal application and how it gets built and how it migrate in terms of state. You have a bunch of folks in here that develop application, write Kubernetes or Docker files, write infrastructure as a code. This is your modern cloud security companies. They write a bunch of code, and that bunch of code span up and create assets. It can be a software asset, it can be an application that is actually a composition of your build file, your website, your API endpoint, and your code that runs behind it. And that gets built inside container. Now, container is not just one entity, but it's a collection of things. It's an operating system, well, it's a VM, it's an operating system, and the application that runs on it. For simplicity of things, we're gonna just think about this in two ways. The application that gets built inside it and the operating system that supports it. And then those things get shipped inside a bunch of other cloud assets. Now, unfortunately, the people that maintain this side of the world doesn't talk to the people that maintain that side of the world. And that's the challenge that we have. So when you ask, hey, is my container secure? I don't know. I don't know what software runs in it. Who owns it? I don't know. I own this part of the world, but for them, it's basically a dark area. And then if you ask these things, is your application secure? Yeah, I've wrote my code, I run my scan, so maybe this part is secure. But is it running in a secure system? Is it running even? The simple question is your application running? Is your repo running? Or what part of the repo is running? That's a very complicated question to ask a developer. So those people try to patch this system. They don't know who owns it, so they leave it. These folks can't report to anything, so the CISO or the security person asks them, can you please fix the vulnerability? I don't know which one to prioritize. So to solve the world, we need to solve this in two different ways. Well, you need four different elements to fix this problem. We need to know the states of a specific thing, so who has generated something and where that something has manifested. It's a concept called lineage. The container actually changed in terms of states. Attribution, who owns what piece of the infrastructure or code, and hence we can attribute the vulnerabilities that we found in these pieces to them. because those are the only people that can solve it. And it's pointless to attribute the container stuff to the operational people, or at least the software part needs to be attributed to the developers, because they are the only people that can actually go and touch your build file, upgrade the library, and so on. But knowing who does what where is the tricky part. But knowing which piece of software gets built in which container and get one where, that's one of the fundamental concepts of reachability analysis. So it's your particular software or your particular library built in a container that is running and is interfaced to the web. So is that particular library reachable? Built inside something, running in runtime. Those are all similar concepts. You're gonna hear them a lot in the industry. There is a lot of noise around this because it seems dark magic, but it's not. It's actually good engineering. Now, there is a lot of companies that are gonna go out there and say, hey, we have the magic formula about reachability analysis. There isn't a magic formula, it's just good engineering. And then the last piece is traceability. So knowing which application runs in which container and then which container runs where. So those are the four concepts: attribution, lineage, code to cloud, reachability, that you need to know or you need to build. And these are the things that we focus in Phoenix to build a complete picture of risk. And to say, focus on this, don't focus on this. Prioritizing is one of the hardest things because it's easy to say that's an important problem, but it's difficult to say that's the important problem to focus on and don't focus on this other one. Because you take the responsibility to say yes to this and no to that. Well, if you're a scanner, you just say, there's a problem. You figure out if it's important for you. We try to go and do the hard things first, because that's a good engineering. So, this is one of the things that we did, for example, with Phoenix, to try to help engineering to identify which app is deployed where and which container is running in which app. We don't call it dark magic, we call it AI. It's actually, there is good engineering behind it. We actually profile your build file, so the list of library that you built. We scan the container, we identify are those same library running in there. We run a profile matching of those two. And if there is a profile match, we tell you, we found X amount of library run here and here that are vulnerable, so probably those two things are running the same things. And then you make the determination if those are good things. This is called lineage or contextual reachability analysis. There is a lot of folks that are gonna go out there and sell you magic or dark magic. Try to ask them what's inside it, because this is how it is done. Don't let them sell you AI. So this is an example of identifying what to fix and what to ignore. Now, I'm gonna go slowly on this, and I'm gonna go through this image 2 or 3 times, so that it's a complicated image, but this is how a piece of software that you see on the left, you have a piece of code with a library. You tend to scan this with 2 different scanners, an open source scanner or a SCA scanner, and a SAS scanner for code scanning. Or you might have a scanner that scans the build file, the application already created. So you might identify the same problem with 3 different scanners. Now that library gets built in a container. I'm gonna skip the part of container scanning and so on. And that container gets shipped in a registry. That registry then, there is some engineering behind, but that register, that container gets run in a number of instances. So your modern CSPM or Cloud Security Posture Management scan here. Your container scanning scan this one. So if you have 2 or 3 scanners, you already have a number of the same vulnerability reported a number of times. Now the problem is, you can't touch those, you can't touch those. That's noise. For a developer, even if you find and you can attribute, hey, you run in this container, and normally you can't, or operational people don't. They run these things and they can't do anything with the results. So what's the fucking point? Sorry for my French, but I've seen them a lot of the time and I'm frustrated about it. It's important to understand what we call pre-live risk and live risk. Now this is library that can be reached, exploited. A vulnerability here is not manifesting, it's not live. So even if you have a vulnerability here and it never get run, ignore it. Somebody might build it in a container and then it becomes a problem. A vulnerability running in a container that is actually being run in a pod, or Helm, or Kubernetes, your flavor of container, is actually a problem that exists. That somebody can go launch a script, attack you, write some piece of code inside your container. Maybe it lives a little bit of time, maybe it lives for a long time. But it's something that is live risk. Now this dichotomy of, yes, you have a live risk, but you can't do anything about it because you need to know which developer needs to fix it. That's one of the things that we do with Phoenix. So this is, for example, for an engineering community, hey, you have a lot of vulnerability in the container, ignore this, fix it here. Fix it in the library where that container got deployed from, got originated from. So this is the concept of reachability analysis. You have a library that gets built in an application and is actually reachable because it's loaded in memory, it's actually live, it's being run. Now to stitch this concept together to say this thing, you need several elements. You need to know, is the container running, yes or no? How many times? It gives you the magnitude of the dangerousness of that particular vulnerability. Is that contained in actually build image? There is the likelihood that that build image will get run somewhere. But to fix it, you need to go and trace the build file where that particular library get originated, built into, and shipped in a container. And the people that maintain this part are not the same people that maintain this one, or it's very unlikely. I know this is very dense, but that's what sits behind reachability analysis. Now you're gonna have a lot of folks that say, hey, we have a method to detect if your library get built in code. So fucking what? You need to know if that library is actually running, otherwise that's again noise. You have people that say, we know that your container is running. Okay, but who fix it? Who can fix that container? That's your whiz of the case, that's your sysdig, that's your lacework, that's your CSPM. Anybody that look at this atomically, it tells you a noise generator, but you can't trace who needs to actually fix the stuff in here. Now there is a piece of it that is called the operating system that you can probably patch or fix, but again, you need to trace where that's coming from. I'm not gonna go in there. I know this is very dense, I know it's getting late, so I'm gonna ask a deck question on this because this is a fundamental element.
So you're scanning the live environments and then you're also scanning the pipelines, the build
Yes.
pipeline. So you can
And
plug,
correlating this two.
right? So you can plug into like Azure DevOps or
Yeah.
what are your favorite pipeline,
Code
Jenkins
builds,
or
whatever.
any of those things.
Yeah.
You plug into there as well as, so you're looking at the source
Or
code.
even if you give us the data, even if you give us the SPOM about this container and the SPOM about this one, we can detect if those are actually running. Now, we can make a guess that those things are running because we don't know if those are actually being loaded, so we'll trust you that you told us, hey, we actually built a container, so here's the container, and you actually, this is the source code analysis, or the SPOM, and then we build the vulnerability around it. So we can correlate those two things and say, hey, these things and these things are actually built together. Yes?
What is the
Can you use the microphone, sorry.
What is the overhead for this? Are you running as a team or are you going to need to be all separate container structure for each exposure to
So that's a very good question. So there is two approaches on this. You're gonna hear reachability analysis run with eBPF or with daemons to actually understand what's the fingerprint in memory. That's very intrusive and very heavy and very data driven, very heavy in terms of data, but it gives you good result because you know every single thing that run a specific snapshot, but it's really heavy to run. And it's really intrusive because you need to know every pod, every system. What we decided to do is a slightly different approach with Profile. It gives you probably 2 to 3% less precisions, but you can run it anywhere with any set of data. If you plug it directly in AWS with Security Hub, with Detector, Inspector, Azure Security Center, your GCP, you scan container in the pipeline, we can get all of that data regardless of where you run your container. We can make that inference because we look at the profile of your container and we look at the profile of your source code and make a correlation of these two.
So the trade-off, where's the trade-off coming from?
The trade-off is not running in every single system or not query every single fingerprint of your memory and analyzing every single call that your code does because that code changes rapidly. So you need a power plant just to understand a very simple thing. So we decided to actually take a different approach that was more flexible, less intrusive, and more widespread. So we can cover every single thing, while a system that works with eBPF needs to have a very precise installation and works probably 2% of the time because it needs a lot of engineering behind it. So you need to involve your engineers to install the daemon, you need to know every single pod, you need to know every single system that runs those containers. So it's very intrusive, it's very heavy, and usually when you make something so hard for engineers, the likelihood that that get implemented, very low. Becomes shelfware very quickly.
So are you importing the severity level or dangers of the code from the scanner, or are you emphasizing through Phoenix that, hey, you gotta take a look at this, you gotta draw attention to this?
Very good question. I like the data-driven approach. So we do both. Let me go. So first of all, we have a problem. We can't agree on a score. If you ask about the same vulnerability, even the National Vulnerability Database, we can't agree on that score. That's a single vulnerability that has 6 scores. And that just, we haven't even talked about reachability or probability. We can't even agree how bad something is in principle.
Correct.
So what we do with Phoenix is we take the base score, the raw dangerousness of a potential vulnerability, and we use that as a starting point. Then we do the first level static analysis if you run our own scanner on SCA, and we know if a particular library is being even built in the system. Now you have 2 approaches about this. You have even function level reachability analysis, a library level, or if a library is loaded, yes or no. Again, more intrusive on one end, it gives you a little bit better result. Your Endor lab will be in that kind of basket, but it's very intrusive because you need to know exactly for every version what things is running and what things are being built, and you need to do a flow path analysis of every single call that you do in your code to understand, is this function being called? And especially when you go very deep, because the library can be nested inside each other and go up to 26 nesting, if not even more. That's impossible. So you can do function reachability analysis can be done at first and second level, otherwise it explodes in terms of complexity. And anybody that is trying to say, we do reachability analysis at the nth level, call BS. Or ask them to prove it, because it's mathematically almost impossible, and it grows in exponentially complexity. So that's the first time of reachability analysis. Is that library even loaded in the system or not? And you'll be surprised about how many times library get left in there. Developers are not lazy, but developers are scared to change things, especially if they haven't touched the code. And with the born of DevOps, everybody change a piece of it without understanding the whole thing. So saying, let's remove this library and let's hope that this function doesn't get called is very scary for a developer to do. So what happens is they leave libraries in the include file forever. And those libraries become vulnerable and they're part of the code. So if you scan that with your OSS or your SCA analysis and your SAST analysis, you're gonna detect those vulnerabilities in that libraries, but they're not even used. So your build file actually doesn't include them, so you can safely ignore them. That's actually the only time I'm gonna say you can actually safely ignore them because they don't exist in your code. They're not getting contained, and nobody can even modify your code at runtime level to code it. So there is no way.
So with that said, do you have a high alert warning system?
Yes.
You do?
Yeah.
Oh, wow, okay.
On that level, yes. But we actually
Not the other ASM piece have that, I don't believe.
you have few of them that actually do good reachability analysis. EndoLab is one of the good guys that do that. But it doesn't include the rest.
So can you do a report up to the CISO or to the
Yeah.
leader that says, hey, you're not taking care of this?
Yeah, because we actually monitor the risk, but we squash the vulnerability. So when we talk about risk, we need to paint a picture for the CISO. So when we talk about live risk, we report about the risk of operational environment and the risk of the application that get deployed and inherit that risk. So we can paint, we're the only one that actually can paint a good risk score of your application being run somewhere. And we can report that to the CISO because the CISO don't care about reachability analysis, library. They just say, how can we reduce our risk, our exposure to this? What we can do is that using that information to then encourage developer to fix what's more impactful and make them look like heroes because they actually get, hey, we actually, with one fix here, we reduce 250 vulnerability in here. And actually, I'm not making that number up. We actually have clients that actually switch off, see if I have that slide, 91% of the libraries. Yeah.
Well, I've seen clients that have 100,000.
So this, without disclosing the vulnerability, this is where we started. Reachability analysis, and we enable another thing called container throttling. So focusing on just X number of version of active image being run. This is data. 91% of vulnerability less. We actually start shaving as well 50% of the SCA vulnerabilities because we disable those containers and we start looking at the vulnerabilities and libraries that are actually reachable. So we actually reduce even that to 12 critical. Again, this is data. So if anybody tries to sell you reachability analysis, ask them to prove them so and how they're gonna do it because it's a very complicated thing. Questions? Is reachability analysis becoming clearer or less clear?
So one thing I didn't see is, are you also looking at which containers are internet facing, which ones
Yeah.
are backend? So that's also part of it.
Yeah. That is your exposure. So I'm gonna jump a few slides and we're gonna make them available for you. So if you're looking at the container level, you need to determine basically which container is running from where. So which container are running or not running and where they're coming from, because you can't fix those. Those provide you risk. You have your exposure of this container. Those are internet facing, not the registry. So you need to know which container is running and how many times it's running. We call them density or exposure. That influences the risk formula, that influences the likelihood of exploitation. Because if the system is completely internal, if it's shielded by compensating control, the likelihood of something to happen is less. Not zero, but less. Where are they coming from? Is an important subject because then you can build the full picture, and this is what we do with Phoenix. Which application use which library, building which container image they get run and then get exposed over the web. So the full, this is what we call lineage, contextual deduplication and reachability analysis to show which application get built, where it get run, which team maintains which part and which team maintains this part. So to build the full picture, and we do that in a almost completely automated way or guided way. This is one of the hardest things you can do because this is a dynamic asset inventory and attribution of which stuff goes where, and switching off the library that or the vulnerability that shouldn't be remediated, and bumping up the library that get actually used. So we say ignore this, or this is less likely, and this is more likely. If I had this several years ago, I wouldn't have had heart attack in HSBC. Nicole? Me and you have seen a lot of this.
Question. So, I understand this is defense first, right? Is there, I think my word of contention with a lot of solutions is that the reactionary mechanism, this is defensive, but is there a reactionary component that can, tie in, let's say, telemetry or visibility from DevOps for anomaly detection, right? Then triggers some sort of like play for. Do you get what I'm saying? Like, this is defense first.
There is some level of telemetry you can do, but usually the metrics that can capture from DevOps is very different from the stuff that you need to actually build attribution or link things together.
No, I understand that, right? I understand that, but I guess when you define play, when you play playbooks, right, for let's say anomaly detection, right? Is there any
To know the problem of bridge is building that bridge.
Yeah.
So this happens even before. So you might have an anomaly on a container, but which application is running on that container? Where is that anomaly happening? And who needs to solve that anomaly or react to that anomaly? That's the problem. So you might have an alert running somewhere, but if you don't know what to need to do with that, so this is a prerequisite to that. If you have this, you know that anomaly, so if you have something that fires up in your SIEM, SOC, somewhere, and you know the container name, maybe it's an AMI, an ARN that runs somewhere, and then you can trace it back to which container gets generated, because you can't fix, for example, a container are ephemeral, so you might switch them off, but you don't know what caused that anomaly. Is that a piece of code or a vulnerability that get exploited? What is the blast radius of that particular vulnerability that got exploited? Where it get coming from? If I rerun that container, is it likely that's gonna re-happen? You just in the dark. You have a signal that get plugged in somewhere, but you don't know where it is, how impactful it is, who's responsible, who is accountable for that. That's the challenge. That's why this is so important, because you move from scanning and reactive to proactive. And switching off stuff, like the whole purpose of this is to say, don't focus on that, focus on this. And it's one of the hardest jobs, but it's the only way we're gonna get the industry forward instead of just reacting consistently to vulnerabilities. Let me do a time check.
7:36.
Yeah.
You got a little 8 o'clock.
Yeah.
Pizza's coming at 8. so-
Pizza's coming at 8. So, are you gonna resist another half an hour?
Yeah.
I promise,
This is great.
that's it.
This is good stuff. I mean.
You're never gonna hear.
roadshow to corporations, because the corporations really need to learn this.
Yeah, there is. What drives me mad is that there is a lot of This is complicated, as you can see. Is deep engineering. It's how software get built, where it get run, who owns what is difficult to know. Only if you've been in a lot of transformation, you know this stuff. So it's very easy for a lot of vendors to come and say, hey, we'll sell you the magic security sparkly things that solve all of your problems, or show you a part of this. If you talk to some of the CSPM, they're gonna show you a part of this. If you talk about some of the OSS or open source security vendor, they're gonna show you a part of this. You know that there is a problem, but you don't know who you need to talk to, or you don't know how bad that problem is gonna be in runtime. So that's the only thing that's gonna stitch runtime with open source software library repo, and you have the likelihood that you're gonna be able to say, hey, Mr. Team of Developer, go and fix that. It's the only way. At least for container, at least for if you're building your code, if you're building your cloud with infrastructure as a code, that is the future. Everybody's gonna build things in this way. So unless you start with these methods, it's unlikely that you're gonna be able to say, hey, Mr. Dev team, fix this. And there are different methods, and there is different things to actually automate a whole lot of it. We have clients that have automated this so that they don't need to configure anything. The DevOps engineers self-declare the ownership of what they built with tags. We attribute things automatically with tagging, and we trace things automatically with our methodology. And they go confirm, deny. And we have different methodology. We have backstage methodology. We have different things to actually use the telemetry, the engineering, the DevOps, the other source of information to actually build this picture so that it becomes automated. And that's the trick, to actually pair up with engineering and use their tools to drive this picture, because this is how they build software. We as security professionals know absolutely nothing about this unless you build software, and it's unlikely that us or the new generation of AppSec folks knows how to build an application in a container, how to run it, how to, exactly.
But aren't some of the security things that have to be built in while you're building the software, and not be layered on top of that?
What do you mean?
Like certain, code that you have to make sure that you're compliant, or, that vulnerability and other stuff that you're baking into your code also.
It's important to actually scan code at this level, but if you don't know who owns that code, or who is their boss, how to enforce it, how to push down objective on them that matters to them, OKR or measurement that are not SLA. Because the first time you literally open an open source scanner in this area, it's gonna throw millions of vulnerability at you, or thousands of vulnerability at you. And you need to make the developer look like hero to say, hey, if you fix this one, the blast radius, the reduction of vulnerability might be massive. So they look good, you look good, security get implemented.
But when you're building code, there are certain applications like Sneak or other apps that actually do the scanning while you're, implementing your code.
Yeah.
So you don't have to do that at a later stage.
Everything that you build is going to become vulnerable at a certain point.
Mhm.
So unless you build on an hourly basis, the likelihood that your Sneak will detect stuff that runs here is very unlikely. So your security tool like Wiz and other tools that speed up this information will fire up alerts that Sneak hasn't detected. But we can correlate those two things and say, hey, you have things here that appears here. So yes, there is tools, there is the advantage of actually building that in IDE, but things becomes vulnerable later on. Vulnerability get discovered, things get upgraded, not all the time Sneak can react faster enough or good enough. I'm not here to throw stone at Sneak.
I got a question.
Yes.
How do you go about coming up with the risk score for legacy code? Code written in the 90s and the 2000s. Since then, there's been a lot of migrations, a lot of improvements. Code written on one system, which was probably secure then, is probably insecure now, and it's live on a new system. And the worst part is, it's written by people who in the 1990s, might as well be ancient Greek.
Yeah, that's the problem of ownership. Like you write code and that code is not code anymore, but it's actually an application that is run somewhere and nobody owns it. Nobody wanna unpack that Pandora box. We had literally pieces of code built in front of stuff because we were terrified to touch the code in itself. So we build layers upon layers. That's why software is complicated. I don't have an answer to that,
And
unfortunately. That's how software get built and inherited. So any company that builds software or that is very legacy will have people that cycle around. So the best chance is try to understand how that code works, or try to understand how that application works, and build compensating control around it, because that's an approach.
Because I used to work in a startup, and we used to work on a security product, and this was a big issue that came up.
Yeah.
Because our clients, they've been existing since the 80s, and they've been digitized since the 90s. So how do you go about securing that code? Is a big question.
It's not a question for a scanner. It's a psychological question for who uses the scanner. So it depends on their risk profile and their risk appetite. Do you put compensating control around it? Do you hire a development team that actually unpack that? I've done it. Like we took a 20 years old software, we re-unpacked it, we rewrote it from scratch without vulnerability, without caring about security at all. We actually re-platform it, but that was a decision, a business decision. Do you put compensating control? Do you shield it? Do you kill it? Do you understand it and fix it? Those are business decisions, but the business needs to have how risky is that application, to which environment, and you have different methods to scan it. If you have the code, you can scan the code. If you have the build file, you can reverse engineer the build file or try to scan and build a profile out of that. Be harder, you detect less, but you can detect something. You can reverse engineer the app. You have different methods, but it's usually a business decision. Brilliant. Any other question on this? Is this finally clear? Did I demystify what the heck is reachability analysis?
Yeah. Well, you're kind of reaching.
Well, that was my objective.
So mostly, the understanding is you take the before and you take the after and you do the analysis on it, you compare the analysis, and then you say what are really the most important.
Correct. And who owns them?
Who owns that?
The other part that we're not showing here is who owns the part on the left, who owns the part on the right. Sometimes they're the same team, sometimes a different team. Because the things that get patched here, these things that runs in here, they still need to be patched. So there is a software component that you see here, but there is also an OSS layer component. So we disable the things that doesn't need to be patched. So if you own these things, you still see the things that you need to patch, upgrade, because there is an operating system component of that component.
So what happens in the left side? You are more on the development environment.
Correct.
Is what you do the scanning, and on the right you do it more on the UAT environment.
In dev, UAT, depending on where you are deploying those containers. Dev,
Right.
UAT, production. So we can actually assign different risk level, different criticality to dev, product, UAT, so that if you're deploying UAT, probably you're shielded. If you're deploying production, probably the impact is going to be different. So that's how we calculate the risk level and the blast radius of specific problems across different stages of the application as well. But that gets complicated and get philosophical on how you calculate risk.
So is it similar to prod? Is what we can run it in the post one, or we have to run it on UAT?
You can run it wherever you want, depending on how deep you want to get into the information. Like some organizations say, even just knowing production, we try to tackle one problem. Somebody can come into the UAT. So the good practice of dividing UAT from dev to prod is that you probably develop crap stuff in dev, then you push it to UAT, you do more testing, you do security testing probably there, and then in production you hope that things get built clean from scratch, not with the same data. Unlikely. That's why I started the company, to actually build things clean, and we never use the same data in different environments. We have fully isolated environment, multiple authentication, but we're lucky enough that we could build security from scratch in software. 90% of the startup that you see, everything gets shipped very quickly. Let's put it this way. we take a little bit more time to ship stuff.
So can you then integrate with issue trackers like Jira, so you can push the issues
Yeah.
into Jira? Because that's where they're going to
In
fix
an
it.
automated way.
Automated.
Yeah. And we're actually going the step beyond. So we're actually building not raising vulnerability, but raising fixes and remedies. So that we can aggregate multiple issues together to recommend you. And that's what the other things that we're using for AI. We haven't published it yet, but we're still working on it. On how we can propose recommendation. That's what we call ourselves actionable ASPM. Because we're actually focusing on the fixes that really matters, not on the issue that really matters. Because with one upgrade or a series of paths of an upgrade, you can upgrade a number of versions of this library with just one path.
So you could push to different, because you got the lineage, you know which team it is, you can push the ticket to the right
Correct.
team. Okay.
And we can do that in an automated way, so you can say, I want to be at this risk level or at this risk level, and we tell you, this is the amount of vulnerability that you need to solve with these fixes, and it's going to take you this amount of time because we monitor as well how quickly are you fixing. So we monitor the velocity on how much you're deploying, so that even if you don't know anything about security and you're a product manager and you're looking at that backlog, you say, do I need to dedicate 5 days of resource time or 50 days of resource time? You give them measurement, and that's why I said, if it's important for your boss, it's going to be important for you. So you gamify this at the business level. And coming from several banks where this was implemented, we actually didn't even talk to the developer about fixing stuff. We talked to their boss and boss of their boss, and we put them in a dashboard and in a scoring system, and they start competing the hell out of it. Nobody wanted to be on the left. Everybody wanted to be right. So we put the good people on the right and the bad people on the left. And they start competing with each other. Executives are very competitive. So gamify the executive, don't gamify security champion and other initiative. Yes?
I don't know if people asked you that before, but how do you know who owns that risk?
That's a very good question. So it depends. It depends where you build it. So we have different methods. So we're building right now attribution and different methods by looking at maintainer file, by looking at code commits and other things to understand who has touched this file at what stage. There is still some challenges because unfortunately GitHub and the Git repos and where code gets stored have very different username from the normal corporate username. So we're still not there yet, so we ask help to engineering to actually translate, hey, if you tag in your repos, declared who owns what. So we created a declarative CMDB that every developer can include a YAML file inside their repo to actually declare this is what I own, and then we put OKR or objective to every engineering community. If you have stuff that is not attributed, we give it to everybody as a bad mark to everybody. So they're gonna try to lower down that element. We haven't solved the problem, but we get in there with some level of automation. So it's not one answer fits all, but it's a mix and match of things.
Yeah, I have that question because I faced a similar issue before that, for example, a cloud compute machine got compromised, and we want to figure out who owns that machine.
Yeah.
There's no way to figure it out because it's cloud. You got cloud users, and that might be a way, but probably some servers account did that.
But that's the stuff that runs here
And
get built from there. So by knowing who builds that stuff, you can attribute these things. So that's the inference that we can do.
but probably not, might be triggered by a service account. How do we know who did that? I mean, how do we find the actual person who did that?
Well, you need to know the owner of these things, of this service. So this is how you do with cloud tagging. And you can build that with, again, another OKR is every infrastructure as a code that you build, if it doesn't have owner attribution inside it, you fail the build.
And here's another question. Maybe all of the resources, they only have one owner. Like maybe their team lead, but actually their engineer did that. But how do we
Well,
find out?
that's a bad ownership. And again, that's a very complicated problem. So you need to iterate until you find, you can attribute to a group of people that are gonna fix the problem. If you go too much up, then it's pointless. You need to have that information because you need to blame somebody to actually go to the bottom. So you get team owner and you get owners inside your infrastructure as a code. It's 2 tags, very simple to do. Ideally, you want to build even application ownership. So the application name or the concept of application. We have clients that actually start embedding that in their infrastructure as a code, and we can use that information to infer which container belongs to that. So we don't need to guess. They are engineers, they know what stuff to do.
So is that a principle of the S bomb or the P bomb, or can
That's
the bomb-
good engineering.
Oh, so the bomb's not going to be able to identify that?
The bomb just say, this is the stuff that get built with this. You still need to attribute, you still need to compose it. You have C bomb at this level, you have SBOM at this level, you have A bomb or application bomb at this level, you have cloud bomb at this level.
How about the I bomb,
What's the I bomb?
the identifier? Come on. Right?
I hate bomb. Those are all assets.
Well, it's the asset, right? Is there a tag?
There are assets in a state. So the SBOM becomes C bomb, they become product bomb, they become runtime bomb. It's just an asset that
Identifier, yeah.
it's a library that have different state that get built in different things. Now somebody created SBOM in a regulation and then he started creating everything. Steve works for an asset company.
Yeah, well, that's where it should be, with the asset.
It is an asset. It is an asset that changed state, that has owners. We have these terms, it's just hard. So we actually call it in a different way and trying to solve the problem in a different way. All right. So, least but not last, you ultimately want to build a picture like this. A funnel. How many vulnerabilities you have on the left that are exploitable, that are weaponizable, that are actually reachable, that are in production, and ultimately out of these, how many of these are critical? Because the things that you need to focus is just a fraction of those. You want to build this picture, you want to build these things because it's hard. It's hard to say not reachable, ignore it. Ignore it. For security, saying ignore it is hard. But it's the only way we can take a stand on burnout, and that's why we created Phoenix, to actually prevent burnout on engineering and actually get something done, get shit done. That's my favorite word. You haven't the time. But to get back to the question on how we calculate all of this and how we string all of this together, we're gonna use a 4-dimensional risk formula. So CVSS and your favorite scoring system is 1 dimension, just how bad it is. You're gonna start moving into the probability analysis of the likelihood of exploitation with 2 dimensions. CVSS, is it exposed or not exposed? Is it likely to get exploited or not? And that's where we go in 4 dimensions, where we bring in the base score, how important is the application, the likelihood of exploitability, and if something is reachable or not. And that's some of the data and the metrics that we use. Is it reachable at network level? Is it reachable when you build it? Is it reachable from a container perspective? Is running in runtime? Is there evidence of exploitation? Is that exploit in a POC stage, just a piece of code somewhere? Is that exploit available? Can I download it? Can I launch it? That makes it weaponizable. So can I download it? Can I use a nuclei, a meta-exploit, any other dummy tool to launch that particular things? Is there evidence of exploitation in the wild? Is that application critical or not critical? It's important for the business. All of that can be stringed along in terms of risk. And that's, by the way, what we do with Phoenix. We actually look at what you built, where you run it, and we paint that for the CISO, for the executive, we gamify for them so that they can set risk-based target and make sense to the 2 community folks. All right, and that's what we call risk. So That's nothing new. It's just base formula of risk. How bad it is, what is the likelihood of exploitation, and atomically how bad that vulnerability is. We wrote tons of books about this. We've done, if you know James Bartoli, good guy, very good guy from an engineering perspective, ex-dev, then moved into security. We've done a very deep talk about this. So if you lost 90% of your brain cell today, you have a way to recover that. I wrote specifically a lot about this reachability analysis and context. That's the stuff that we do with Phoenix. We do basically all of the vulnerability that happens. We scan it from code to cloud. We have a graph that basically attributes which one of these assets get built where. We do create vulnerability lists for engineers, prioritize vulnerability lists, and help you setting targets that actually are meaningful and get shit done. That's not the marketing term, but that's in a nutshell what we do. We help you get shit done. If you wanna read about more why our reachability analysis is cool, again, data-driven, evidence-driven, we have all of the data in there, and we explain instead of just sparkling marketing terms, because I wanna make sure that you can trust what we say. Not always when I speak, but you can also read about it. So, we are part of a community. With this community, we actually write books, we write blogs, we write webinars. So if you want to be part of it, we have a Slack community. In there, everything is open source, everything is available. We're here to actually make sure that everybody gets better together. We have a OWASP version of Phoenix so that everybody can scan their code, their cloud. Of course, it's limited because we need to make money as well about it. But we try to do something good for OWASP and the community and get everybody to be able to scan their OSS and scan their runtime as well as container and web stuff. But we also write it, so I brought some of the book that we wrote available for everybody. First come, first serve, first sign, first serve. If you want to write the next one with us, let me know. That's it. Pizza is supposed to be coming now. I don't know if it's out there. Any moment.
Yeah.
There should be some beer left and some drinks.
All right.
Questions? Thank you very much, folks. I know it was long.
Actually, invited me to Canary tokens. I've never heard of that before.
Which one of them?
I never heard of Canary token. Can you tell me what a Canary token is?
A canary token is a piece of software, it's an alarm. So like in the mines, you had canaries. So if they smell gas, they start singing. If they die,
Okay.
is probably you should run. So canary token is a piece of software or is a piece of code that runs somewhere. There are canary tokens that are embedded inside document to identify, and they call home, basically call a server. If somebody steals that piece of document, or they can run in a server to get triggered. They're very similar as Honeynet, to get triggered if somebody attacked that particular port, that particular exploit, that particular system. So it's a way to detect. It's more on the detection side than the prevention side.
Gotcha.
And there is, like reachability analysis, there is variation of canary token. By the way, if you prefer the digital edition of the book, actually this is not it. We actually wrote 4 books. So this is my battle against SLA. So to go from SLA to risk. And this was the digital version of the book. So if you want to download this one in PDF, you can get it through here. Now let me see. So we have as well one thing for you guys. I would like to, we had the digital methods, but we're gonna try to make it analog. So hat and names, write your names, pass it around. You can write your name, get rough write your name, remove it, and put it in the hat. We have a raffle for noise cancelling headphones. We have a digital version of it, but today has been a bit of a drop. So we're gonna go back in our
Write your name, like rip off a piece of paper, write your name down.
tear it out, and then put it in the hat. My English is going further and worse.